Hey guys, here today to talk about degrees and radians. So usually we talk about things in our last unit of triangles and all that stuff in terms of degrees. So let's say usually I'll have like a 150 degree angle. But now we're going to be talking about something called radians. All right, so radians are new for a lot of us, but for the most part, we're not going to cover a whole lot of the concept behind radians in grade 10. You will see it in terms of how it has an arc and a sector and all of those things in grade 11. If you'd like to know more about that now, and if you're hungry for it, I'd consult page 456 in your textbook. But here we're going to just show you the nuts and bolts of how to convert things from degrees to radians and back again. So as we look at it, really the difference between degrees and radians is just some conversion factor. So you've seen these before in chemistry and physics, and you're talking about miles per hour or meters per second and those types of things. So here, if I want to go from degrees all the way over to radians, well, I have to multiply my degrees by, so multiply this here, by pi over 180. So pi is going to be the result of a lot of these calculations. You will leave pi in your answer, and it's communicating something to us that this is in radian measurement. So this is really important at higher levels of mathematics, and it makes things a little bit easier for us to carry through when we're doing more complex calculations. Another way to look at it too is if I'm going from radians, and if I have a conversion factor that gets me going one way, of course I have to multiply it by the other way in order to get back into degrees. So I'd say 180 over pi. And let us not forget that this is 180 degrees, so I'll put a little degree sign on top of those things. So here I'm going from degrees to radians, I'm multiplying by pi over 180. If I'm going from radians to degrees, I'm multiplying by 180 over pi. So let's get into a couple examples of this, and let's start with a first example, number 1. So we're looking at 150 degrees, and I want to get that into some radian measurement. So as I look at my chart above, I will say that I have 150 degrees. All right, so I'll multiply that by pi all over 180 degrees. And when you're using a conversion factor like this appropriately, your degree sign will cancel, or your unit on the top and the bottom here will cancel. So I'm left with 150 pi all over 180. Now, what this might not be technically wrong as far as the radian measurement goes, we really appreciate using radians in their simplest form. So I look at the top and the bottom here, and I say, well, what can both of these be divided by? And a nice common number here would be 30, right? So I want to get this into simplest form. 3 would be great, but I notice that I got 15 and 18 if I disregard those zeros. So I can boil that down and actually say that this is going to be 5 pi all over 6. So when you're getting used to radian measurement, a lot of the time it's going to be tough going from this step here, where you just multiplied, into the simplifying form. So this is the simplified form of this radian here. You're going to take a couple of stabs at this and trying to figure out how to do it, but ultimately it's just dividing by the largest thing that will divide the top and the bottom that's common. So let's do another example here. Let's do going back the other way. So here I'm going to take part 2. I'm going to go from 7 pi all over 6, and I'm going to get that into degree form, right? So these can go forward and backward. Now, a lot of the times you'll notice that we're going from degrees to radians in this second half of trig unit, but it can also go both ways. So depending on how your answer needs to be expressed. So here's 7 pi over 6. I'm going to multiply this time by the flip of this conversion from up here. So remember, if I'm going from the radians over to degrees, I have to use the 180 all over pi. So this will be 180 all over pi. So 7 times 180, and that's going to give me a really big number here. That's going to give me, oh, hold on a second, I don't have my calculator and my mental math skills are not so good today, so let's try this out. 7 times 180 degrees. That's going to give me 1260, and that's all over 6. Now notice here how my pi's were on top and I had one on the bottom over here, and those will cancel out for me altogether. And if I were to divide 1260 by 6, I will find that this is going to be a 210 degree angle. And I got a little lazy here. I should have had that degree sign on the 180 as well. So here I figured out that my 7 pi over 6 radian measurement for an angle is actually 210 degrees. Let's do one more going from degrees to radians, because we're going to see more of those as we progress. So here I'm going to say that I have a 30 degree angle and I want to get that into radians. So I multiply that by pi all over 180, and that'll give me, again, 30 pi over 180 degrees. And so the degrees cancel, so I know I did that conversion right, but again, it's that simplification to a new answer that will be tripping you up at the beginning. So I look and I say that both of these can be divided by 30. So in its simplest form, I'm going to say that this is just pi over 6 for this angle right here. So really, the number one takeaway from this video is that you are able to use this concept going from degrees to radians or radians to degrees. If you'd like to know more about radians, again, take a look in your textbook, ask your teacher, and take a look at a couple of problems for you to practice before you move on to the next video.